All right, so we're going to look at 5-3. Don't forget that 5-2 you're still responsible for, and 5-1. All of those identities that you had to learn, they still come into play here, so don't throw those notes away. If you did, go back and print them back out again because you're going to need them. They'll be on your final exam in May. So for 5-3, you can see here, I love this feature, hang on. You can see right here, it's my laser, isn't that fabulous? You have to learn all of these. It's my like Star Wars laser. And so it seems a little overwhelming at first that you have to learn 6 more formulas. But this is really not that bad. If you think about how overwhelming it was to learn all those identities in 5-1, this is nothing. You can learn 6. There's a pattern. And the pattern is very simple. You just have to practice the pattern, study the pattern, and learn the pattern. So look at the sign. Just the sign right here, those two. And really, all we're going to do is take let's say that I want to find the sine of 75 degrees without my calculator. So if I'm going to find the sine of 75 degrees, I'm going to use any kind of angles for my special right triangles, 30, 60, 45, or my north, south, east, west axis points, 0, 90, 180, 270, and 360. I can use any combination of those with these formulas to help find something that I can't do on my own. So for instance, if I use my special right triangles, are there 2 angle measures, 30, 60, 45, that add up or subtract to give me 75? What'd you say? 30 and 45. So I could convert the sine of 75 to the sine of 30 degrees plus 45 degrees. Which means that now I'm going to be using, since this right here is addition, that means I'm going to be using this one right here because it's the sine of one angle plus another angle. So that's your sum. And somebody much smarter than you or I went and derived these formulas. If you want me to show you how they are derived, you probably would want me to put you away for a while because you really don't want to care about that. We can if you want to at a different point. You can talk to me later and we'll go through why, but accept it as is for right now. So look at the sine ones. What do you notice about the pattern right here? Sine, cosine, cosine, sine. What is this one down here? The same exact pattern, isn't it? It goes sine, cosine, then cosine, sine. Notice that the first angle, which they're calling U, and the second angle, which they're calling V, never changes position. It goes first, second. First, second. Same thing here. Notice all the way along here, the first and the second angles never change positions, okay? But the pattern changes. Look at your cosine, these two right here. Don't they have the same pattern? It goes cosine, cosine, then sine, sine for both of them. So sine goes sine, or sine, cosine, cosine, sine. And then sine goes cosine, cosine, sine, sine, always for these. Then look at the sines. So if I start here with a plus, did the sign stay the same or change? With a minus, stay the same or change? So with sine, think sine, sine stays the same. But with cosine, we have a plus here and it changes to a negative. So the cosine actually changes signs, where the sine doesn't. Sine stays the same, cosine changes signs in the middle. Then we come to your tangent right here. The easiest way, because the tangent ones look more complicated, so the easiest way to remember it, isn't tangent sine over cosine? So look at the signs here. We've got positive and positive. Isn't sine, which is in the numerator for tangent, doesn't the sign for sine stay the same? Sine is in the numerator. Sine over here, the signs stay the same. So it makes sense that the plus and the plus stay the same. Then for cosine, cosine's in the denominator for tangent. Notice for cosine, the sign changed. We went here from a plus to a minus. So if you think sine over cosine, sine stays the same. Cosine, the sign changes. That makes sense for those signs. It can help you remember whether it's a plus or a minus. And the pattern for both of these are the same. You've got tan of the first and tan of the second. tan of the first, tan of the second, and then in the denominator for both of these you have a 1, and then you're multiplying tan. The only difference between these two are the signs. Other than that, they are identical. So then your job in this entire section is to get to know these formulas, use them, learn them, love them, because then we're going to start to apply them. So let's go ahead and look at this very first problem right here. A little crooked, right? All right, so we're going to find the exact, and it's important that you note that it says exact. So it says exact. Oh, it says exact value of cosine of 75. I could just plug into my calculator the exact value for the cosine of 75 degrees, and I'd be done. It'd be quick, done. But they want the exact answer, which implies that we're going to have some, probably some radicals in here. So let's go ahead and use our formulas above. And before we do that, let's actually go back. Let's go back over here, and I want to put in my special right triangles. So the first one that we're going to look at is when we have 30 degrees. So then 60 would be here. What's across from 30? 1. What's across from 60? Rad 3. And the hypotenuse is 2. That's a 2. Shocking but true. Let me fix it. I just wanted to use the eraser. So 2. And then let's change our point of view. Instead of having the 30 in the lower left, we're going to put the 60 here. It's always better to write things out so you don't have to remember it. You can just look. Same thing. Across from 30 is still 1. Across from the 60 is radical 3. And the hypotenuse is 2. And the last one is, I'm going to put the 45, 45. I don't want that there. I want to put the 45, 45 over here. So the legs on the 45, 45 are 1, and the hypotenuse is radical 2. But when you look at sine and cosine for the 45, 45, starting to lose my voice. I want you to recall that sine is opposite over adjacent, which would be 1 over rad 2, but we want the rationalized version. So square root of 2 over 2. And then the cosine, we want to use the rationalized version also, and the cosine is adjacent over hypotenuse, which would again be 1 over rad 2, but we want the rationalized version, rad 2 over 2. So now let's go ahead and work that example. All right, so we're going to find the exact value. Because it's cosine of 75, I don't know what the value of the cosine of 75 degrees is, but oh, interesting, that won't erase. Well, we'll have to ignore it. What numbers can I add or subtract to give me 75? 30 and 45. So I'm going to replace the cosine of 75 with a cosine of, and it doesn't matter what order you write them in. You can do 45 plus 30 and you'll get exactly the same answer as I have. We're going to apply the formula that's above. And what's the pattern for cosine? What does it say above? Cosine, cosine, sine, sine. So that's what we're going to do. So we've got cosine of the first, which is 30 degrees. And then cosine of the second, which is 45. And then look at the sign. Does the sign, which is currently positive, does the sign stay the same? Or does it change with cosine? So this sign here, it changes to its opposite sign, which is minus in this case. And then now we switch to sine. So we have sine, sine. But the order of the angles, they don't change. So I'm still going to use 30. So sine of 30 and sine of 45. Is anybody confused as to where I got those? If we're taking notes, can't fall asleep. Then all we do from here is substitution. So use your special right triangles that we drew above, and we're going to substitute in values for cosines and sines of those 30 and 45 degree angles. So for there we go. So what is the cosine of 30 degrees? Cosine is caught another hippie, adjacent over hypotenuse. So what is it? Radical 3 over 2, and then times, what's the cosine of 45 degrees? Remember we said that we're going to use that rad 2 over 2, and then the cosine of 45 and the sine of 45 are identical. And then we've got minus sine. What's the sine of 30? Sine is some old hippie, so opposite over hypotenuse. 1/2 times, what's the sine of 45? Rad 2 over 2. And then all we have to do from here is actually perform the math. So you can multiply what's ever underneath the radical to what's underneath the radical, and what's outside a radical to what's outside. So I can multiply that rad 3 to that rad 2, and what do I get? Rad 6. So I get radical 6 over, don't forget to do 2 times 2 right here. Don't forget the 2 times 2, which is 4. And then minus 1 times radical 2 is radical 2. 2 times 2 is 4. Because they're over the same denominator, can't I combine them as one fraction? And so we will. Oops. Sorry. So we get radical 6 minus radical 2 all over 4. And so this is my exact answer. So you can then take your calculator, and if you punch out on your calculator radical 6 minus radical 2 over 4, you get the following answer. Approximately you get 0.2588 I'm going to stop at that. So that's what that exact answer is approximately equal to. If I'm going to punch cosine of 75 degrees into my calculator, if I'm putting degrees on my calculator, what do I want the mode of my calculator to be? In degrees. So if you have your calculator, go ahead and check your mode, make sure it's in degrees, and then just punch in cosine of 75. Guess what it turns out to be? The same exact value. So test it. Questions on what we did there? Does it make sense? Yes? No? Yeah, you're so exhausted after your first day back, aren't you? Okay, so let's go ahead and go to example 2. So example 2, we're evaluating a trig function again, but this time we have radian measure of pi over 12. Do you like radian measure? Well, I don't either. So instead, we're going to do step 1. We are going to convert pi over 12 to degrees. So we're going to take pi over 12 and multiply it by its conversion factor. What conversion factor do we use? 180. Why do I hear talking? Over pi. So your pi's cancel. What is 180 divided by 12? You have a calculator, use it. What do you get? Nope. Nope. The calculator should give you 15 degrees. That's a degrees. Not a very good degrees. Whoops, I don't want that either. Degrees. All right, so we've converted pi over 12 to 15 degrees. One of the things you do want to make sure is that you are paying attention to what quadrant you're in. And both example 1 and example 2, we are in quadrant 1. So here's where my 15 degrees ends up being. And the reason for that is if I happen to be in quadrant 2, 3, or 4, it's going to affect the sign of cosine sine and tangent. And so you might have to adjust. And so when you're doing your homework tonight, which I highly suggest you do your homework so that you come across those situations, you can ask those questions, and we can do the problems up on the board. If you don't do your homework, you won't know to ask the questions, and the chance will be lost. All right, so we're going to use 15 degrees, and I want to use 30, 60, and 45 to add or subtract to come up with a value of 15. So sine of what? What can I convert? 45 and minus 30. So sine of 45 degrees minus 30 degrees. Will you agree that that gives us a positive 15? Or there's another one. Sine of 60 degrees minus 45. That's a minus. You get to choose. You choose. It doesn't matter which one of these you do. They will both be exactly the same answer. I choose this one because I don't like 60 degrees. I prefer 30 degrees. That's the only reason why. It really doesn't matter. So then from here, we're going to apply our difference formula for sine. So what is the pattern for sine? Sine, cosine, then cosine, sine. So we're going to start off with sine of the first angle, which is 45, and then cosine of the second angle, which is 30. And then does the sine stay the same in sine, or does it change? Stays the same, so we still have a minus here because the inside sign there was negative, so this remains the same. And then we change to doing cosine of the first, which is 45, sine of the second, which is 30. So from here, we're just going to substitute. So what is the sine of 45? From above, it's rad 2 over 2 times, what's the cosine of 30? Cosine, caught another hippie. Rad 3 over 2, and then minus cosine of 45. Rad 2 over 2 times the sine of 30. 1 over 2. And then we're just going to perform the math. So rad 2 times rad 3 is radical 6. 2 times 2 is 4, minus rad 2 times 1 is rad 2. 2 times 2 is 4. Because they're over the same denominator, you can combine them as one fraction. And it appears to be a coincidence that this is exactly the same answer as example 1. But it's really not such a coincidence. You want to know why? What is 75 and 15 to each other? They are 75 plus 15, and we probably, there it is, 15. They're complementary to each other, aren't they? And if you go back to 5-1 where we had what's wrong? We're laughing, smiling, it's not that funny. So go back to 5-1 where we had our co-identities. Remember where it said the sine of pi over 2 minus theta is equal to the cosine of theta, and vice versa, the cosine of pi over 2 minus theta is equal to the sine of theta? Those were complementary. The sine and the cosine of complementary angles are exactly the same measure, and that's what this is showing you here and here. And so it's just a reminder of those co-identities, so that makes sense. All right, so then let's look at example 3. Example 3, I don't want that. Example 3 has 4 parts to it. We are expressing as a single sine, cosine, or tangent. And so it doesn't matter that I don't know what the sine of 42 degrees is or what the cosine of 12 degrees is. That makes no difference whatsoever. what I'm trying to find is not the value, but I'm trying to break it down into just one value. So go ahead and look at the pattern of the sines and cosines. So here we have sine, cosine, then the second part is cosine, sine. That pattern, is that for the sines, the cosines, or the tangents? That matches the sine pattern, doesn't it? So I know that we're dealing with the sum or the difference of sine. And then our angles, which are 42 and 12, they stay in the same order. Those don't change. So I've got 42 and I have 12. The question comes to play, what's the sine? So this sine right here, if my pattern follows sine, does sine stay the same or does it change? It stays the same. So I know that there's a minus in here. And then I can finish off by just doing the math. So I end up with a sine of 30 degrees, which actually we do know is 1/2, but they didn't ask for that. They just asked for the tangent or the trig function. So you're getting to know your formulas in reverse. So then look at the second one. So again, let's look for the pattern. The first one is cosine, cosine, and then we have sine, sine. What does that match? Sine, cosine, or tangent? Cosine. So I know that my function is cosine. And then my angles are pi over 3 and pi over 4, and they stay in that order. Pi over 3 and pi over 4. I just have to figure out what the sine is. So does the sign stay the same or change? So if it was a plus, it changes to a minus. And then we have to perform the math. The problem with this is we don't have like denominators. What is the like denominator between 3 and 4? 12. So I need to make them both into 12. So the first one gets multiplied by 4, top and bottom. And the second one gets multiplied by 3, top and bottom. And so we end up with cosine of 4 pi over 12 minus 3 pi over 12. What does that give you? Cosine of pi over 12. And then the last one, don't let it bother you that we don't know our angles, that they're x and 2x. That doesn't matter. Again, we're looking at the pattern. So we've got sine, sine, and cosine, cosine. What does that appear to be mimicking? Cosine. But if you look above for the cosine sum and differences, isn't it always cosine, cosine, sine, sine? Cosine should come first, shouldn't it? And furthermore, if cosine comes first here, that means that my cosine has a negative in front of it. Do either of the cosine sum or difference formulas have a negative in front of the cosine? Matthew Thomas, sit up. No. So if I were to write this in the correct order, the order would be negative cosine of x, cosine of 2x, plus sine of x, sine of 2x. And that would be incorrect, and we can't use that formula because it would have a negative in front of the cosine. How can I fix it so there's not a negative in front of the cosine? How do I take a negative out? If I multiply, I change the value. If I divide, I change the value. Instead, I can do what? Factor it out. So that's what I want to do instead. I'm going to factor a negative out from both of them. So I'm going to factor a negative out. So I get a negative 1 out in front. And if you will bear with me, I'm going to factor the negative out of here and make this a negative and put it second, and factor the negative out of here and put it first. So I can kind of skip a step. So I end up with cosine of x, cosine of 2x, and then the sign becomes negative, so minus sine of x, sine of 2x. Now it's in the proper form. So we already said that it mimics cosine, right? So we've got, actually I'm going to change this into brackets. You'll see why. So it mimics cosine because of the cosine, cosine, sine, sine. Now it properly mimics it. The angles are x and 2x, and they stay in that order. That's a nice x, can you tell? Now all we have to do is figure out the sine. Does the sine, which is currently negative here, does it stay the same in cosine or does it change? It changes. So this becomes a plus in the middle here. And then this should finish off with brackets. So don't forget about the negative out in front. That gives us a negative. And then it's cosine of what's x plus 2x? 3x. Done. Any issues with that? All right, so then examples 4 and 5 deal with proving reduction formulas. Emphasize on that lovely word, prove. Remember what proving meant? All right, so we get to make one side look like the other side. So you might want to write yourself a little note. The reason why it says a reduction formula because it only occurs when you have multiples of pi over 2. So write yourself a little note. If one of the angles in the sum or difference is a multiple of 90 degrees or pi over 2, then the formula becomes more simple. And you'll see what I mean here in a minute. If you thought my writing was worse before, or bad before, it's worse here. Yay. So if you can't read something, let me know. So it's important to realize that what they have here is this pi. Pi is a multiple of pi over 2. So is any of the 4 north, south, east, west axis points. 0, pi over 2, pi, 3 pi over 2, 2 pi. Any of those are considered multiples. And if you think about it, look at the coordinate system. Here's pi. Right here. What is the ordered pair at pi? It's negative 1, 0. And bear in mind that that means that the negative 1 is the cosine and the 0 is the sine, because remember it goes alphabetically. Rory, wake up. And so we're going to use our knowledge. I'm going to work on just the left side here of this equation. So we're just going to look at the left side. We're going to apply the sine sum formula. So what is the pattern of sine? Sine, cosine, cosine, sine. So we've got sine of the first, which is x, and then cosine of the second, which is pi. And does the sign change or stay the same? Stays the same, so we have a plus, and then we go to cosine of the first, which is x, sine of the second, which is pi. So then all we're going to do is replace what we can replace. So I can't do anything with sine of x, so it stays sine of x. Times what is the cosine of pi? Remember what we said it was here? So isn't the cosine of pi negative 1? So we're going to replace the cosine of pi with negative 1. Plus cosine of x I can't do anything with. times, what is the sine of pi? 0. Then finish off the work. The sine of, what's the sine of x times 1? Negative 1, sorry. Negative sine of x. And then plus, what's cosine of x times 0? 0. And if you add those together, don't you finish with negative sine of x? And isn't that what's on the right side of the equal sign? So this right here equals this right here, and that's your whole goal. So then let's do B. We do the same thing, but this time, look at where, this time we're using 3 pi over 2. So we need to look at where's 3 pi over 2. 3 pi over 2 is here. What is the ordered pair at 3 pi over 2? 0, negative 1. And so remember, the 0 is your cosine, and the negative 1 this time is your sine. And so I'm going to apply, because we have cosine here, I'm going to apply the sum formula for cosine. So what's the pattern for cosine? Cosine, cosine, sine, sine, and does the sign in the middle stay the same or change? It changes. So, Jason, I hope we're not texting, because there shouldn't be much. Just because you get to use your phone for translation doesn't mean we should be texting. So we've got cosine, cosine of the first, which is x, times cosine of the second, which is 3 pi over 2. Our sign stays this, or I'm sorry, our sign changes to a negative. And then we'd switch to sine of the first, sine of the second. And then we're just going to substitute. What is, well, I can't do anything with cosine of x, so that stays cosine of x. What's the cosine of 3 pi over 2? Yeah, right here, remember, 0. So we're going to replace that with 0, so times 0, minus, I can't do anything with the sine of x, times, what is the sine of 3 pi over 2? Negative 1. And, following your math, if I take cosine times 0, I have 0. And then if I take negative sine of x times negative 1, that negative sine of x changes to a positive sine of x, so I end up with a plus sine of x. And if you add those two together, I get just the sine of x. And isn't that the same as what's on the right side? So there's your goal. So the last one that we're going to do is a little bit more hairy, because it's tangent. We haven't done much with tangent yet. But let's look at, this one is 3 pi over 2 again. So using our same coordinate grid that we just had, let's look at, here's 3 pi over 2. Remember, the ordered pair is 0, negative 1, and cosine is a 0 and sine is a negative 1. So if I were to find tangents of 3 pi over 2, what would that equal? Tangent is what over what? Sine over cosine. So sine is negative 1, cosine is 0. What does that equal? What's that value? Undefined. Can I put undefined into a formula? No. So let's go back to the top, all the way back to the top. If you look at these formulas right here, if I were to put undefined into any one of these tangents, I can't. I don't know what to do with that. So if I can't put undefined in here, I can't use these formulas. So if I can't use these formulas, then I'm using these formulas. How do I convert tangents into sines and cosines? What is tangent equal to? Sine over cosine. So what's going to happen is I'm going to use one sine and one cosine. So I'm going to have a sine summary difference in the numerator and a cosine summary difference in the denominator. So here we go. Okay. So we are going to come. And the first is theta, then cosine of the second, and the second is 3 pi over 2. Then does the sign stay the same or change? It stays the same, and it's negative. And so then we reverse it, cosine of the first, which is theta, and then sine of the second, which is 3 pi over 2. And all of that is over. So that's just the first one, right? Then we have to do the denominator, which is cosine, the difference formula for that. So what's the pattern for cosine? Cosine, cosine, sine, sine. So we have cosine of the first, which is theta, cosine of the second, which is 3 pi over 2. Does the sign change or stay the same? It changes. Since it was negative, it becomes positive. And then we're back to switching to sine of the first, which is theta, and sine of the second, which is 3 pi over 2. Then I'm just going to substitute values in based upon what we did here. These values I know. I know sine and cosine of 3 pi over 2, and those are the values I'm subbing in for. So I can't do anything for sine of theta, so it stays sine of theta times, but what's my cosine for 3 pi over 2? What's my cosine? 0. So I'm replacing that with 0. Then minus, I can't do anything with cosine of theta, but I can replace sine of 3 pi over 2 with what? -1. All over, now do the denominator. I can't change cosine of theta times, but again, isn't the cosine of 3 pi over 2 the same as it was above? 0. Plus, because our sign, remember, in the denominator is plus, I cannot change sine of theta times, and then just as it was up here, the sine of 3 pi over 2 is -1 equals. Then we're just doing the math. So sine of theta times 0 is 0, minus, actually, what's a negative cosine times a -1? So it's a positive cosine of theta, all over, we've got cosine of theta times 0, and so that is 0. And then sine of theta times -1 makes it negative sine of theta. Why are you packing up? Just checking. And then we're going to keep going, follow that math. We get cosine of theta up top and negative sine of theta in the denominator. What does that equal? Not just cotangent, but it's got a positive over a negative, so it's negative cotangent of theta. And isn't that right here exactly the same as the right side was over here? So what are we going to make sure we do tonight? Please do your homework.